All right. We are taking the look at a quick one, direction of reversible reactions, and kind of what these look like on a particulate rate. So this depends on the rate of the forward and reverse reactions, then equilibrium, we're going overall one reaction or another. So they're equal, but eventually they do change over time. And AP Test likes to ask a lot about these of like what's going on with the forward and reverse reaction rate at this time, and so on. So in this case, if we have N2O4 breaking down to produce NO2, and then nitrogen dioxide producing dinitrogen tetroxide, these are both happening at their own speeds. When we put them together, we would show a mixture of both. Okay? We would show a mixture of both happening on both sides. Even though we think of these as happening as, reactants making products and reactants making products, we would see concentrations of both of these. So that's something to be often thought of when you think of which direction these are going. Higher concentrations might be leading you to think that there's going to be more going to become products, or if there's more products, they might be forced to become reactants. They often will ask questions of how this changes over time, or what is it at the start, what is it at the finish, and so on. These are good questions that can trip up smart kids just because you think of chemical equilibrium, equal rates, boom, they're the same. Another good example is the idea if you have a closed system, the evaporation of the liquid is going to equal the condensation of the liquid. Okay? When we increase temperature, both are going to occur and increase the rates equally. This is often not thought of, but you probably see this when you have on a warm day, you have a lot of condensation along the sides, and that'll collect off to be larger droplets, which will then come down, pool in, and have more evaporate. So you can see that the rates both increase equally. Other ways that things can change over time, thinking of how our blood works. This is a very complicated thing to put in, but I thought it might be interesting that the heme group, we think of hemoglobin and how it bonds to oxygen, that when we have more oxygen present, like in our lungs, that forces this to be taken on. When we have less oxygen in our cells, then that pulls off the oxygen, leaving it now without it. Depending on the concentrations of oxygen, it'll either be forward or reverse reaction based upon what's present. When we have a solution that's being dissolved, when we have a lot of the solid, there's going to be a lot of dissolving of the solid and less deposition or coming down from ions to the solid. When it's saturated, now we have equal amounts because the amount that's already here is depositing, and some of those depositing ones are dissolving. So this becomes equal again. So often they like using pictures to illustrate if equilibrium is reached, if it's approaching, going towards the reactant side, going towards the product side. So keeping in mind of what these pictures look like gives you an idea of the stability. And again, equal rates of reaction, equal rates of both dissolving and deposition, oxygen being absorbed and released, the previous ones, condensation, evaporation, one chemical becoming another. Get used to these types of illustrations and see if you come in with any questions. All right, take care.